Okay, so in this one we're going to do an E1 elimination. So you can see that I've got the question up here. So the question takes this substrate, treats it with sodium hydroxide, and you get an E1 type mechanism. So E1 mechanism, the leaving group leaves first. So my leaving group is this bromine. So you've got the bromine coming up like this. Sorry, if we look at everything in the plane. So you've got your phenyl group like this, the bromine's coming forward, the hydrogen's going back in relation to me. Then on the other side, the phenyl group is going up, the hydrogen's coming forward, and the methyl group is going back. So in an E1 elimination, the leaving group leaves. So we're going to make it leave. And we end up with this carbocationic intermediate, which I'm going to say is planar, because otherwise I'd have to switch in and out with different carbon atoms. So this leads to this intermediate here. So you've got the H up, pH down, and then you've got your pH, the benzene ring, still going up to where it was, because we haven't messed with this end. We've got to this point. We now need to get this proton, which will be removed by the base, such that the p orbital that's coming up and out of here, those two need to be aligned. So we have two ways of doing this, and you can see that I've done two ways of doing this. So if we go to the right first, this is possibly the more obvious one, I guess, where if you make it so that this H is in line with where that p orbital would be, you'd end up with an alkene across here, which would mean that your pHs are cis to each other, and your CH3 is going back, as shown in this diagram. This isn't ideal because your two benzene rings are going to be interacting with each other, which we don't necessarily want, so you're going to have steric issues. The alternative, if I go back to where we were here, so the pH up, the H forward and the methyl back, is to go so that this H is up. So in this case, we end up with the H up, and it's aligned with this p orbital that would be here. And we can take it, so if we remove this proton here with our base, I'll need to change my bonds, but if I put on one of the double bonds to start with, and then put on the other one. Ooh, I've now confused myself. Nope, there we go. So it's very easy to confuse yourself. And in this case, the pH groups need to be trans to each other, so opposite sides of the double bond. And there we end up with this.